Greetings students, welcome back to our YouTube channel Nagin Best Digital Learning. Today in this video we will discuss about a topic named combination of resistors or resistances, and there are basically two types of combinations which can be used to combine the resistances, that is, one is series combination and another is parallel combination. See, for practical purposes we have to connect more than one resistors, and these resistors can be joined either in series or in parallel. या तो हम किसी भी रेजिस्टर्स को सीरीज दो या दो से ज़्यादा रेजिस्टेंसेस को या रेजिस्टर्स को हम सीरीज में कनेक्ट कर सकते हैं या पैरेलल में कनेक्ट कर सकते हैं. सीरीज कॉम्बिनेशन का इस्तेमाल हम वहाँ करते हैं जहाँ हमें ओवरऑल रेजिस्टेंस की वैल्यू ज़्यादा चाहिए होती है और करंट को हमें कंट्रोल करना होता है, डिक्रीज करना होता है. जबकि पैरेलल कॉम्बिनेशन का इस्तेमाल हम वहाँ करते हैं जहाँ ओवरऑल सर्किट का रेजिस्टेंस हमें डिक्रीज करना होता है और करंट हमें इंक्रीज करना होता है. Let us discuss first of all the resistors or resistances in series. A number of resistances are said to be connected in series if these are joined end to end and same current flows through each. How we can identify that the resistances are connected in series? First of all, the head of first one and the tail of first one should be connected to the head of second one. In this particular arrangement, if the resistances are connected, and one more point is, if the same current is flowing among all the resistances, then we can say that all the resistances joined in that particular order are the resistances connected in series. Suppose here is a diagram R1, R2 and R3. In between points A and B, there are three basic resistance R1, R2 and R3. These are connected to a potential difference V such that the total current I flowing through R1 flows through R2 also and R3 also. It means the same current is flowing through all the three resistances. But in series combination, we have to keep in mind that the potential difference will be variable for all the three resistances. Suppose V is the total potential difference, then for let us consider for resistance R1 it is using V1 potential difference, R2 it is using V2 potential difference, and R3 it is using V3 potential difference. In series combination, the overall current remains the same while the potential gets divided as per the resistances. Now we have to draw an equivalent circuit like this. In place of R1, R2 and R3, I have written in this equivalent circuit a total resistance Rs. This is the resistance Rs I have written. This Rs is the equivalent resistance, or it will give the same effect. This single resistance will give the same effect of the resistances as R1, R2 and R3 combined will give the effect in the circuit. वैसा ही इफेक्ट आर एस प्रोड्यूस करेगा इक्विवेलेंट रेजिस्टेंस, जैसा कि आर वन, आर टू, आर थ्री तीनों एक साथ मिलकर करते। तो इसीलिए हमने इन तीनों की जगह पे एक आर एस पर्टिकुलर रेजिस्टेंस को नोट डाउन किया। इन दिस पर्टिकुलर पॉइंट हमें यहाँ साफ साफ दिखाई दे रहा है कि जो वैल्यू डिवाइड हो रही है, करंट बिल्कुल भी यहाँ डिवाइड नहीं होता है सीरीज कॉम्बिनेशन में, जबकि पोटेंशियल है वो डिवाइड हो रहा है यहाँ V1, V2, V3 के अंदर। सो वी विल राइट द इक्वेशन फॉर पोटेंशियल विच इज रिटन लाइक दिस, कैपिटल V इज इक्वल्स टू V1 प्लस V2 प्लस V3। नाउ एज पर ओम्स लॉ, as per Ohm's law, the value of V1 it will becomes I into R1, because I is the same for all the resistances, so it will remains I, and R1, R2, R3 these are different, so V1 is equal to I into R1. Similarly, V2, the potential difference across or the potential drop across R2 resistance is given as I into R2, and as like for V3 it is I into R3. Now for that particular equivalent resistance circuit, V must be equal to I into Rs. I is the total current and Rs is the equivalent resistance that we have written in place of R1, R2 and R3. So from equation this and this, we can write Rs is equal to R1 plus R2 plus R3. How I have written this? Let us understand first. Suppose our first equation was V1 is equals to I into R1, V2 is equals to I into R2, and V3 is equal to I into R3. These are the potential drop across R1, R2 and R3 resistances, and our equation was V is equals to V1 plus V2 plus V3, and further we have written V is equal to I into Rs, R equivalent, and we will put the value of I1, I2, I3 like this. Suppose I have taken common, it will becomes R1 plus R2 plus R3. Then for both the sides I will be cancels out, and it will becomes Rs is equals to R1 plus R2 plus R3. Then for series combination we can write equivalent resistance is equal to R1 plus R2 plus R3. That's why the same formula is written here. Rs is equal to R1 plus R2 plus R3. From this formula we can say that if a number of resistances are connected in series, then their equivalent or resultant resistance, that is the sum of individual resistance, and which is greater than any individual resistance. Means that the value of equivalent resistance will be always greater than the value of individual greater resistance. From here, we can say some more points also. We can summarize. If there are n resistors, n identical resistors means हर एक रेजिस्टेंस की वैल्यू वहां पर सेम है, R1, R2, R3 up to n resistances are there and each resistance value is capital R. Then how we can write RS? RS is equal to R plus R plus R, this one, up to n times. It will becomes n into R. N into R. Suppose we have 10 resistances each of 100 ohm and we have to find out equivalent resistance, then simply R equivalent, it will becomes n into R. N means number. How many number of resistances? 10. Then 10 into capital R is value of one single resistance, that is 100. It will becomes 1000 ohm. This is how we can find out the value of equivalent resistance if identical resistances are given to us. Now the point third is the potential difference across the ends of the combination is distributed across the ends of each one of the resistors. The potential difference across any of the resistors is directly proportional to the resistance. मीन्स पॉइंट थर्ड हमें क्या बताता है कि जिस रेजिस्टेंस की वैल्यू जितनी ज़्यादा होगी वो रेजिस्टेंस उतना ही ज़्यादा सीरीज के अंदर पोटेंशियल इस्तेमाल करेगा. एज वी नो V इज इक्वल्स टू IR. I सीरीज के अंदर फिक्स है तो V इज डायरेक्टली प्रोपोर्शनल टू R. ग्रेटर इज द R, ग्रेटर इज द पोटेंशियल कंजप्शन. Now, point fourth, the equivalent resistance RS, it will produces the same result that gives the same current under the same condition when the same potential difference is applied across its ends when connected in place of series combination. In place of R1, R2, R3 up to Rn, suppose the combination, the same result which the combination of R1, R2 and R3 that will give, only single RS resistance will also give the same result. Now point fifth, to connect resistance in series is the same as to increase the length of the conductor. It is due to the reason that the resistance of the combination increases and is equal to the sum of individual resistances, and it is obviously greater than that of any of the resistances combination. It means if we will increase the same number of or the same resistances, it means it is like that we are increasing the length of a conductor, because as the length is increased, the resistance will also be increased in the same ratio as per length, because we have already discussed that resistance is directly proportional to length. Now the second combination is resistors or resistances in parallel. if a number of resistances are said to be connected in parallel when if one end of each resistor is connected to one point and other end is connected to another point such that the potential difference across each resistor is same. You can clearly see in this diagram the one end of resistance is connected in this point and this resistance point is connected in this point. तीनों जो ही रेजिस्टेंस हैं R1 R2 R3 इन तीनों के जो कॉमन पॉइंट्स हैं वो एक ही जगह पर कनेक्टेड हैं। इधर से भी यहाँ इसके लिए भी और इसके लिए भी एक ही पॉइंट पर तीनों कनेक्टेड हैं और इस अकॉर्डिंगली कि यहाँ का जो पोटेंशियल डिफरेंस है इस पॉइंट का इन तीनों के लिए सेम है और इस पॉइंट का जो पोटेंशियल डिफरेंस है वो भी इन तीनों के लिए सेम है। इस कॉम्बिनेशन में अगर रेजिस्टेंसेस कनेक्ट हों कि उन सब का एक पर्टिकुलर पॉइंट एक कॉमन पॉइंट पे हो, दूसरा पर्टिकुलर पॉइंट दूसरे कॉमन पॉइंट पे हो, इस तरह से कि हर एक के अंदर पोटेंशियल डिफरेंस हमेशा सेम रहे, ऐसे रेजिस्टेंसेस को हम कहते हैं कि इस तरह के रेजिस्टेंसेस पैरेलल कॉम्बिनेशन में कनेक्टेड हैं। पैरेलल में पोटेंशियल डिफरेंस सभी रेजिस्टेंसेस के अक्रॉस सेम रहने वाला है और जो करंट की वैल्यू है इट विल बी डिफरेंट। नाउ अगर हम यहाँ पर भी एक पर्टिकुलर अरेंजमेंट करें दैट इज इक्विवेलेंट रेजिस्टेंस, यहाँ हमने इक्विवेलेंट रेजिस्टेंस को आर पी कंसीडर किया है। आर पी इज द इक्विवेलेंट रेजिस्टेंस इन पैरेलल कॉम्बिनेशन। तो इन पैरेलल कॉम्बिनेशन करंट इज डिवाइडेड। तो हमारे पास यहाँ एक पर्टिकुलर इक्वेशन सामने क्या आती है, R1 इज इक्वल्स टू I इज इक्वल्स टू I1 प्लस I2 प्लस I3। दिस इज आवर बेसिक इक्वेशन। क्योंकि करंट यहाँ पैरेलल के अंदर डिवाइड हो रहा है तो I इज इक्वल्स टू I1 प्लस I2 प्लस I3। तो करंट की वैल्यू अगर हम R1 R2 R3 के लिए यहाँ से कैलकुलेट करें तो I1 के लिए वैल्यू हमारे पास आती है I1 इज इक्वल्स टू V बाय में R1, दिस इज द फर्स्ट वैल्यू। I2 इज इक्वल्स टू V बाय में R2, ऐसे ही I3 इज इक्वल्स टू V डिवाइड बाय R3। तीनों ही I1 I2 I3 की वैल्यू हमारे पास आ चुकी हैं। इन तीनों ही वैल्यूज़ को जब हम इस इक्वेशन फर्स्ट में पुट करेंगे तो हमारे पास जो I इज इक्वल्स टू V बाय R1 प्लस V बाय R2 प्लस V बाय R3 ये वैल्यू हमारे पास आ जाएगी। लेकिन जो हमने इक्विवेलेंट रेजिस्टेंस बनाया है उस इक्विवेलेंट रेजिस्टेंस के केस में I इज इक्वल्स टू V डिवाइड बाय R इक्विवेलेंट होगा। तो जब इन सभी इक्वेशंस को हम कंबाइन करेंगे तो हमारे पास ओवरऑल ये फॉर्मूला सामने आएगा 1 बाय आर पी इज इक्वल्स टू 1 बाय R1 प्लस 1 बाय R2 प्लस 1 बाय R3। चलिए देखते हैं ये इक्वेशन यहाँ किस अकॉर्डिंगली हमने लिखी है। सपोज हमारे पास जो बेसिक इक्वेशन थी I इज इक्वल्स टू I1 प्लस I2 प्लस I3। I के लिए हमने जो वैल्यू कैलकुलेट की थी दैट इज इक्वल टू V डिवाइड बाय आर पी। I1 इज इक्वल्स टू V डिवाइड बाय में R1, I2 इज इक्वल्स टू V बाय में R2, I3 इज इक्वल्स टू V डिवाइड बाय में R3। V दोनों तरफ से हम कॉमन लेंगे तो ये कैंसल आउट होगा, तो हमारे पास नेट रिजल्ट आएगा 1 बाय आर पी इज इक्वल्स टू 1 बाय R1 प्लस 1 बाय R2 प्लस 1/R3। ये हमारे पास पैरेलल के अंदर नेट रेजिस्टेंस आ जाएगा, जो कि हमारी इक्वेशन बनती है 1/RP इज इक्वल्स टू 1/R1 प्लस 1/R2 प्लस 1/R3। This is the equation which is proved this time. It means we can say that when a number of resistances are connected in parallel, then the reciprocal of equivalent or resistance is equal to the sum of reciprocal of individual resistance, and that individual resultant resistance is the smaller than any individual resistance. जो रिजल्टेंट रेजिस्टेंस है उसकी वैल्यू किसी भी इंडिविजुअल रेजिस्टेंस की वैल्यू से हमेशा छोटी होगी. देयर आर ऑल्सो some points that we should keep in mind while solving the problems. Suppose first of all, if there are n resistors, n identical resistors means each resistance value is R and they are connected in parallel, then their equivalent resistance is given by Rp is equals to R divided by N. Suppose we have given 10 resistances and each resistance value is 100 ohm. We have to find out the equivalent resistance, that is Rp. It will be R divided by N. What is R? R is the value of one resistance. It is given 100 here, and N is the total number of resistances. It will becomes 10 ohm. Then we will get the resistance of 10 resistances, each of 100 ohm in parallel combination. Their equivalent resistance becomes 10 ohm. Another point number second, the potential difference across each resistor in parallel combination remains the same. And the main current, point number third, the main current I, it will divide itself as a different current flows through each resistor. Because in parallel combination, potential difference remains the same and the current will get divided among each the resistances. It depends on the value of resistor. The equivalent resistance Rp, it will also produce the same result as R1, R2, R3's reciprocal will give the result to us. Now, the point fifth is connecting a number of resistors in parallel is like providing an equal number of path for the flow of electrons that will result decrease in the overall resistances. If suppose R1 and R2, if we will consider only for two resistances R1 and R2, this particular formula can be used to find out the equivalent resistance value. Rp is equals to R1 R2 divided by R1 plus R2. Further, the very last point and eighth one is, if there are n resistors, each of resistance capital R, then their series combination is NR and their parallel combination is R divided by N. Most of the time it is asked that find out the ratio of series to parallel combination. We can write it like this: nr divided by r by n, it will be equal to n square. It will all, the ratio of series combination to parallel combination will becomes equal to the n square.